Start recording. Recording has started. All right. Wait a couple more seconds here. I think we've been getting a lot of participants, so I'm really happy about that. Okay. Well, let's go ahead and get started. I'm Andrew Swenson. I'm Principal Planner for the IMPO. This project is an update of the CMAQ submittal worksheet. It's a project we've been working on for a little while, and we've just finished our basic improvements, and we're ready to present the tool to you and talk about it a little bit. I'll provide the agenda here. The reasons for the update, the primary reason, at least the project that started almost a year ago, is that we wanted to update our emissions rates. Our emissions rates were only good to 2025, and our projects were going past 2025. And our emissions rates were from the MOVES 2014B model, and we wanted to move to the MOVES 5 model, which is the present model. Oh, here we go. And we wanted to make sure we were able to accommodate years 2025 to 2035. In addition, we had an HNTB study done at the end of 2024 and 2025, looking at the spreadsheet and looking at ways of improving it. Come in. The HMS was just trying to make sure that I have good. We have 26 participants. Okay. I just was looking at the privacy policy, which is in the chat. So if you want to go ahead and look all the privacy policies, you're able to do that. The address issue, we also wanted to address another. Go ahead. Anyway, the address delay issue. We addressed delayed issues. There are a couple of project types that rely on calculations of delay, and the spreadsheet used. It's not HMS. That's the boat. The highway
capacity manual.
Capacity manual, HCM. I was thinking about the Titanic, but that's okay. It was using HCM values from 2000 and 2010, and that had become increasingly outdated. We had one of our consultants who was submitting a project point that out, so we had HNTB observe that as well. And we also noted that part of that issue that generates, we have an increasing number of intersection types. We wanted to address primarily intersections and signal coordination. Intersections was our by far largest category of CMAQ projects that have been submitted. Finally, there were some general cleanup questions that we knew about, but then we came across later during the process. General cleanup, cell color questions, and some formula issues. So that was the primary history of the project. The CMAQ spreadsheet's been in place since about 2014. And now we're doing pretty much a long overdue update, I think. So the agenda for today is to provide introductions of all these folks, and that might take a little while. We've got 28 people online, so that's really nice. And then we're doing a history of we've done the history of the CMAQ workbook tool, the reasons for the update. So those were two of the items, although Coordino will mention those reasons again, I believe, in their presentation. The Coordino group will do a presentation, and then we'll get questions from you folks as to additional changes and suggestions. We're probably going to be kind of limited in what we can do this year, but we certainly will at least address any glaring omissions, and we will also put this on a list for a future update. And that's my email address, and I won't leave that up there for too long. I'm going to have Ryan share. I'm going to stop sharing, and then Ryan Way, who is with the Coordino group, or Johnny Hahn, will introduce we'll do our introductions first. So I'm going to go across the board. I'm Andrew Swenson, I'm Principal Planner for the IMPO. Cole Jackson can introduce himself, and then we'll go through the other people.
Yeah, Cole Jackson with the IMPO.
Okay, Jeff Hill. Jeff Hill's.
Jeff Hill, A&F Engineering. Morning, all.
Okay. Aaron Kaler.
Aaron Cater, Town of Brownsburg.
Okay. Jim Hellman.
Jim Hellman, City of Noblesville.
Okay. Michael Pierce.
Michael Pierce, City of Westfield.
Philip Roth.
Philip Roth, American Structure Point.
Ryan Way.
Ryan Wei, modeler from the Crodino Group.
Okay. Johnny Hahn.
Johnny Han with Corodino.
Okay. Andrew Rodwald.
Andrew Rodewald from City of Noblesville.
Okay. Tucker Bourne.
Tucker Bourne, Indianapolis DPW.
Mark Witzman. Mark, you're muted. Okay, skip Mark for a second. Daniel Johnston.
Daniel Johnston with Johnson County.
Okay. Tammy Houston.
From Houston, City of Fishers.
Okay. Andrew Wolf.
Andrew Wolf with Crossroad Engineers.
David Benefiel.
Dave Benefiel with the Anderson MPO.
Okay. Steve Cunningham.
Steve Cunningham with the MPO, Indianapolis MPO.
Haseb Guman.
Steve Bowman, DLZ.
Okay, thank you. Amanda Meyer.
Amanda Meyer, Mobility Manager and Assistant Director at CERTA, Central Indiana Regional Transportation Authority.
Welcome. Joseph Rengel.
Joe Rangel representing Westfield.
Joe Palmer.
Joe Palmer, City of Indianapolis.
Jared Huff.
Jared Huff, City of Carmel.
Shengnan Liu.
Shengnan with the Corodino Group.
Shashad Gujaran.
Shashad Gujran, Traffic Engineer with American Structure Point.
Okay. Aaron Katar. Aaron. And, okay. Ooh, now I've got another list. That's interesting. Okay. Jordan Hasley, I'm sorry.
Jordan Hasley, DLZ.
And Mark St. John.
Mark St. John, City of Indianapolis.
I think that may be everyone here. Was there anybody else we missed here in this introductions part?
It's Mark Witzman, Town of McCordsville.
Okay. Thanks, Mark. I was just going off the pictures on the page. So hope you got as much. If I missed you, it's not because I want to ignore you. All right. So that gets us to the introductions. I'm going to go ahead and we're going to go ahead and go to Corodino's presentation. I'll stop sharing. And Ryan Way or Johnny Hahn, I don't know who's taking
me. Ryan will do.
Okay. Okay.
You can see my screen?
Yeah.
Yes.
I can see.
Okay, cool. Yeah. Okay. So good morning, everyone. Thank you for joining. So this project is a collaboration between IMPO and the Corodino Group. Today, we will walk through the CMAQ tool, why it is important, and highlight the recent updates we've made together. So here is today's presentation agenda. We will cover three main topics. First, we will have a brief introduction to the CMAQ tool. Then we will talk about the CMAQ tool update to highlight the major changes and improvements in the methodology and tool structure. And we also have the emission rates update. So first, let's have introduction to the CMAQ tool. So what is it? So the full name of CMAQ is Congestion Mitigation and Air Quality Tool, which is an emission calculator that helps IMPO evaluate projects for CMAQ funding and prepare the required annual reporting. It estimates reductions in pollutants such as NOx, VOC, PM 2.5, SO2, CO, and greenhouse gases. And then the next question is when it was developed. So the tool was first developed in 2014 by Cambridge Systematics for IMPO. It was adapted from a similar tool used by the Atlanta Regional Commission, but tailored into Indianapolis conditions with several new strategies added. So the original version uses the EPA's older MOVES 2014 model with locally developed emission rates, and it only covers years 2015 to 2025 across 11 strategies grouped into roadway operations, transit expansion, and travel demand management. And why we are updating it? Because under the current update, Corodino has enhanced the tool in several key ways. First, we replaced the older emission rates with the most updated MOVES 5 based rates for 2025 and 2035. And we also streamlined the methodology to allow direct use of travel time and delay results from the, for example, Synchro or Sidra, and updated the strategy tabs for compatibility with the new emission years. And I want to mention that this project specifically focused on the tools of tab 2.2, 2.3, A to D, and 2.4, with the goal of making the tool more flexible and easier to use. So first, let's see the tab 2.2. So this tab or approach, which is called signal synchronization, which is to evaluate the emission benefit of synchronizing traffic signals along a corridor so that vehicles can encounter multiple green lights, which we often call a green wave, when traveling at a reasonable speed. So in the previous, this is the previous method. You can see the screenshot here. Travel time savings at each intersection were calculated individually and then aggregated using a delay reduction factor. So these processes rely on several inputs, such as the number of intersections, number of lanes, average cycle length, and volumes during peak periods, and use a HCM-based formulation and converting these savings into emission benefits. And in our updated approach, all of those detailed calculations from the old method have been eliminated. Instead, travel time savings are now set directly as input. You can see here, the text may be a little small, but you can see here. So the direct input include the average corridor travel time during peak period, before improvements and after improvements. And several other inputs include the scenario year, corridor length, average traffic volume during peak hour, and percentage of trucks. You can see that the inputs here are much less compared with before, because we set the travel time savings as direct input for the engineers. So this method, and also 2 columns of inputs are needed. One is for peak direction in the morning, and one is for the peak direction in the PM peak hour. So based on the feedback from engineers, we also modified the wording in the tool to make it clear. So previously, this label said morning peak inbound, but we've changed to AM peak hour peak direction, which better reflects how the data should be entered. So by doing this, we avoid the long list of parameters required in the previous method and instead rely on actual travel time results. This makes the process more accurate, more flexible, and much less cumbersome than before. And then I will talk about the next section. So this section includes several tabs. In the previous two include the 2.3A from D, and 2.4. So this section focuses on individual intersections and a roundabout and was not intended for corridor level or network-wide assessment. So in the previous method, improvements were defined as 4 intersection types plus 1 roundabout types. So I will briefly go through all these types. So first, type A is a new signal, so which is to convert an unsignalized intersection that was into a signalized intersection. And type B is adding a new movement or changing a permissive turn into a protected turn or adjusting the signal by adjusting the signal phasing and timing. And type C is called capacity and phase, which is to make geometric changes, redesigning approaches or increase capacity in a way that improves level of service. The type D is called new signal plus turn length. So this is to convert an unsignalized intersection into a signalized one and adding turn lengths to handle higher traffic volumes. And finally, the roundabout is to replacing either an unsignalized or an signalized intersection with a roundabout. For each of these types, the average delay reduction per vehicle was estimated using HCM-based method and then aggregated to determine the total delay reduction, which formed the basis of calculating the emission benefit. And this approach often relies on large number of input to calculate the delay using the outdated HCM-based formulations. And also another key limitation is that the roundabout method did not fully account for geometric design features such as size, shape, and layout that can have a major effect on the delay calculation. And I will give you an example of the previous tool. As you can see on these slides, the screenshot here. So this is the screenshot of the type D intersection new signal and turn length. We can see that there are a large number of required inputs, and engineers had to fill in all of these cells, which made the process very complicated and burdensome. And that's why we are improving this tool by eliminating all these complicated inputs. So our updated method minimized many of the limitations of the previous approach by shifting to a much simpler and more flexible input system. So instead of filling in a long list of parameters, engineers now only need to provide 4 key inputs. So first is the scenario year and the percentage of trucks. I want to note that the percentage of trucks is the volume weighted average across all directions and total vehicle hour of delay during the peak hour, both before and after the improvements. And these delay reduction values are these 2 delay reduction values are calculated directly using the professional traffic software such as Synchro or Sidra, and then entered directly into this tool. This makes the process much more streamlined and user-friendly. It also accommodates a wider range of intersection and roundabout improvements and configurations. And and also I want to mention that previously for this section, there are totally 5 tabs into 2.3, A to D, and 2.4. And now they are all merged into a single section called section 2.3. And as you can see on this picture, so this tab includes all the types in the previous slide. And finally, I want to talk about the emission rates update. So for this update, both running and idling emission rates were redeveloped using the most updated EPA's MOVES 5 model and at the county scale for Marin County. So the rates covered 2025 and 2035 under typical weekday conditions. And the results are organized in the new tools, Excel tools. And the moves input were built from the most recent IMPO dataset to stay consistent with the fleet mix and speeds, VMT, age distribution, and meteorology, etc. And 6 sets of runs were conducted to capture seasonal and pollutant-specific differences. So for the annual run, this includes the CO2, PM2.5, NOx, and SO2. And for the summer conditions, it includes NOx, VOC, and winter conditions includes the CO. And in the emission update, 2 types of run rates were prepared. The first is the running emission rates. It was directly generated from the MOVES5 and aggregated by VMT to match the CMAQ categories. And all the running rates are expressed in grams per mile. And for the idling emission rates are expressed in grams per hour. And finally, we compared our current 2025 rates compared with the previous 2025 rates. And the consistency confirmed that the new methodology and inputs are reliable for the CMAQ evaluations. And that's all of my presentation. Later on, I will open up the the CMAQ tools before and after side by side to compare. And for now, this is the end of my slides. So this presentation concludes our overview of the updated CMAQ tool. And at this point, I want to pause and open it up for the questions. Please feel free to ask about anything that you have questions.
Does anybody have any questions for the Coordino group at this point?
Ryan, I've got a question. This is Andrew Wolf with Crossroads.
Mm-hmm.
The roundabout post delay, you mentioned it's an input. Do you want the average delay of the intersection or at the peak hour, or the worst delay on the approach?
We normally look for the average delay for the entire intersection.
Yeah, it includes all the directions.
Yeah. Do you have a follow-up for that?
No, I just wanted to make sure I clarified on that one.
Okay.
Yeah, if no more questions, I will compare the tools before and after side by side, and we can go to some details of the tool. Yeah, let me share my.
Oh my gosh.
This.
Very friendly. Okay.
So I will put the updated tool on the right hand side and the original tool on the left side. As you can see, there are many tabs in the original tool, but we only updated the tab 2.2, 2.3, A, B, C, D, and 2.4, as well as the emission rates. And for example, for the 2.2, as we can see, previously it has much more inputs here because these inputs are serving for calculate the travel time savings using the outdated HCM based formulations. And this time we just provide, let me make it bigger. Yeah. So this time we just provide the average corridor travel time before improvements and after improvements, so that these two eliminate the HCM based calculations. and the engineers can directly get these travel time from the traffic simulation software and make them as direct input to calculate the emissions reduction. And yeah, that's the synchronization tab 2.2. And then I will talk about the other tabs. So for example, this is the tab before the previous tool has it called intersection new signal. You can see there are much more inputs here, and also the new phase. And this is the capacity and phase type, and also the new signal type. And you can see that this and roundabout tab, you can see all these input structures are different because every type they have different they have designed a type of inputs that let the tools to calculate the delay reduction, and that relies on a lot of inputs by the engineers, and that is very complicated for the engineer to input correctly for all these inputs. And for our most updated tool, you can see we combine all the previous tabs into one intersection and roundabout improvements. As you can see, the inputs are much less here. We only care about the scenario here and the percentage of trucks. And also we have two crucial inputs here. One is vehicle hour delay before improvements, and one is vehicle hour delay after improvements, so that the engineers can calculate the total delay before and after directly from their traffic simulation software, and provide them as direct input here, so that these tools can accommodate more intersection types and roundabout geometry, and it is much easier and user-friendly for engineers to have these inputs. You can see that there's only like 4 cells for the engineer to do that. And previously, you can see, for example, the new signal returning movements. There are a lot of inputs here, and it's really hard to use. And that is for these tabs that we that's all the tabs that we have updated. And I also want to mention that we also update the emission rates here. So previously, you can see the emission rates are for 2015 and 2025. And this time we are updating it to 2025 and 2035, uses the most updated most 5 software. And we have checked the consistency of these emission rates, and they're pretty consistent with previous tools we have. So for now, we think that that's all the tabs we have updated. And you have any questions regarding the tools and the updated tabs and emission rates? I will show it here by side comparison here.
I guess Ryan and Andy, sorry, I've got another question about these changes.
Mhm.
Is the MPO going to put out a recommendation or guideline for, standard values for some of these modeling softwares, so that we kind of get apples to apples comparisons across the communities?
I think I paid you to do that. The agenda has, yes, we have discussed that a great deal. Normally what happens is, when we've gotten Sidra or Synchro output in the past, we sometimes have received like a 40-page document. And that's going to be hard for us to, one of the things we want to make sure we do as we make this transition is to make sure that calculations are done in a fair way, that people submitting calculations are doing the similar things. We haven't yet come up with a good secondary sheet, kind of just a checklist of what we want to receive from those products. And we probably will need to have some expertise, somebody who has expertise in those products to help guide us a little bit and providing that data, for our October 6th submittal of projects. So what I might be doing is reaching out to you folks. If you have specific expertise in those two products, we are going to be looking. I think in general, we have engineering staff from H&TB reviewing these documents as they come in. So we won't be totally at sea, but we want to make sure that we simplify that process for you folks too, so you don't have to present, so we can minimize the amount of time that we spend examining the materials. That is a good topic. If other people in the conversation want to weigh in, that'd be something that we be part of this particular meeting as we get ready for implementation of this sheet. I think first of all, we wanted to make sure we had any questions about the sheet itself and whether there was any problems with it from your folks' perspective.
Yeah, I think I just missed something, and we also update the colors of this Excel sheet. And for now, the yellow represent the user inputs, so that the only fields that the engineers need to care about. And the blue are the constants and emission factors, and the blue and the green cells here are all the outputs and the calculated values. And also we added some tags here, so indicating that these results are dedicated for MITIP project website usage. And you can see this is the previous Excel tool. As you can see, these colors are not very consistent and sometimes may cause confusion. So this time we just change this and we just make sure that all the colors are consistent across all other tabs, and it's straightforward and more clear to use.
Ryan, for the scenario year, is there a drop down for 2030 and 35? Is that?
No, it's not drop down. You can it's drop down from
The 2030 is what we want to select for this year's call.
No, for the scenario year, you can enter the values from 2025 to 2035.
Sorry.
Yeah.
And then the delay is now in vehicle hours as opposed to seconds per vehicle on the previous sheet.
Yeah, previous sheet, I think they first calculate the individual delay, then sum up to the total delay, and that's a calculation process. But this time we just provide the total vehicle hour delay in hours for the engineers to input the result from their software.
Yeah, I think that's a good point. I see the Sidra output is vehicles per second. So yeah, we just need to make sure that we convert that to hours.
Right. Yeah, we'll have to calculate that.
Does the synchro require the same conversion?
I'm not a synchro expert, so I'd have to defer to somebody else.
Yes, I believe so. That's correct. They all give you overall intersection seconds per vehicle delay.
Yeah, that might be a recommendation. If you can change that to seconds, that way the manual entry doesn't get goofed up on calculation, and the calculations just ran through the blue.
Okay, so you are talking about you suggest to change it to seconds, and then we convert into hours in the Excel tool.
that would be the requirement. I mean, if we got it in seconds, we'd have to change it to hours to get to the delay. Then we'd have to make a delay calculation of some sort. Okay, just a change in values at the bottom in the output. Okay, I'm not hearing any other comments from folks out there. Any other, aside from the documentation issue, most of this is, and I think we'll go ahead and change to seconds because I think that seems like it's a pretty easy fix, Ryan.
Yeah.
Okay. We'll go ahead and shift that to seconds so that you folks can just enter the seconds, hours per second, or vehicles per second delay. So if there's nothing else, what we'll probably do then from this is we'll send out the spreadsheet. We'll have it posted on our MyTip website. Kristen Sanchez is online here. Kristen's in charge. Kristen and Cole are from the tip section. Oh, Steve is as well. Kristen and Cole are the primary keepers of the MyTip application process. We're going to go ahead and work on the documentation question over the next couple of weeks before the submittal. So we'll be looking for, if we might be reaching out to you folks for specific, if you could put in the chat that you have Synchro or Sidro experience and are willing to help us with that. Just make sure we want to check that whatever you submit is going to be easy for you to do and easy for us to check. So we'll have to work on that over the next couple of weeks, but I think the spreadsheet is ready to post after those changes. And we'll then work with whoever wants to submit CMAQ projects. I would suggest that folks get going early for October 6th so that we could make sure we have those processes in place and have time to review everything this first go round. And then we'll continue to finalize submission standards, over that time and use that experience to really understand what the submission looks like and what we need to have. So that's where we're going with this. I'm awful glad you folks could all show up. This is a pretty nice turnout. So I appreciate you folks coming. And that's about it for today. We're a little bit early in terms of ending the session, but if you folks, if there's nothing else from you folks, we'll just give you your day back, and we'll continue to work with you on this. Make sure we're willing to listen to whatever you need. So thanks very much for coming.
Thank you.
Thanks, guys.
Yep.
Thank you.
Thank you.
Yeah.